Every week or so, in preparing an episode of this podcast, I sit down to write down my thoughts on some subdomain of psychology or philosophy relevant to consciousness. Before I write them, they cannot be said to be my thoughts, or in any case, I don't have them ahead of time. Rather, I discover them. The thoughts arise, and I give them voice upon the page. Or do I? I don't really know how to translate abstract concepts into words. As I write this now, I am as much a reader and a critic as I am its author. If I am an emergent product of what is happening in this brain, and so are my thoughts, do I not stand beside them as a phenomenon rather than ahead of them as their producer? Indeed, I do not think these thoughts are mine at all. They are the thoughts of this brain when stimulated thusly, and I am their curator. The ones that please me, or at least seem sensible and worth saying, those are the ones that remain on the page. The others are culled away by the backspace key. I determine which of the thoughts that occur to me are good and which are bad. Or do I even do that? Thoughts are like perceptions, but the act of thinking is not quite like the act of perceiving. Perceiving isn't really an act at all. Thinking implies a kind of movement. A step is being made, a reflection is occurring upon something, rather than a simple observation of the thing just as it is. One thing is being related to another, is either moving in one direction or another direction. In general, thinking seems to be a prefrontal cortical function. What we are thinking about, though, has to involve posterior brain regions because that is where perception occurs. For example, thinking of a particular face requires activation of the fusiform face area, spanning between parts of the occipital and temporal lobes. That is where facial perception occurs too. But willfully thinking of a face should involve the prefrontal cortex in communication with the fusiform face area. The willful part is prefrontal, along with directing attention to or reasoning about faces. So in my view, thinking is prefrontal, but thoughts are products of other cortical regions. If thoughts are the contents which occur to us in consciousness, and the prefrontal cortex is doing indirect operations on thoughts, or causing them to occur in consciousness, is the prefrontal cortex directly involved in consciousness? I came across a Viewpoint article called, "Does the Prefrontal Cortex Play an Essential Role in Consciousness?" It was written by Omri, Raccah, Ned Block, and Kieran Fox in 2021. Here's the abstract, quote, "A central debate in philosophy and neuroscience pertains to whether prefrontal cortical activity plays an essential role in the neural basis of consciousness. Neuroimaging and electrophysiology studies have revealed that the contents of consciousness or of conscious perceptual experience can be successfully decoded from prefrontal cortical activity, but these findings might be confounded by post-perceptual cognitive processes such as thinking, reasoning, and decision-making that are not necessary for consciousness. To clarify the involvement of the prefrontal cortex in consciousness, we present a synthesis of research that has used intracranial electrical stimulation, IES, for the causal modulation of neural activity in the human prefrontal cortex. This research provides compelling evidence that IES of only certain prefrontal regions, i.e. orbital frontal cortex and anterior cingulate cortex, reliably perturbs conscious experience. Conversely, stimulation of anterolateral prefrontal cortex sites, often considered crucial in higher order and global workspace theories of consciousness, seldom elicits any reportable alterations in consciousness. Furthermore, the wide variety of IES-elicited effects in the prefrontal cortex, e.g. emotions, thoughts, and olfactory and visual hallucinations, exhibits no clear relation to the immediate environment. Therefore, there is no evidence for the kinds of alterations in ongoing perceptual experience that would be predicted by higher order or global workspace theories. Nevertheless, effects in the orbital, frontal, and anterior cingulate cortices suggest a specific role for these prefrontal cortex subregions in supporting emotional aspects of conscious experience. Overall, this evidence presents a challenge for higher order and global workspace theories, which commonly point to the prefrontal cortex as the basis for conscious perception based on correlative and possibly confounded information." Unquote. The authors of this article focus on studies using intracranial electrical stimulation, IES, of regions of the prefrontal cortex. In their words, IES provides probably the best means of causally perturbing brain function in humans. Their ambition is to determine whether the prefrontal cortex produces conscious perceptions or whether its activity is a byproduct or response to conscious perceptions occurring elsewhere in the brain. My expectation is that the prefrontal cortex is involved in aspects of attention, thinking, motivation, and emotion rather than sensory perception. But there are those who disagree, especially in the domain of global neuronal workspace theory. In my papers on the TICL, I suggested a different way of interpreting global neuronal workspace theory that would correct for this prefrontal bias. I think the framework could be improved that way for sure, and perhaps in time it will be. Let's take a look at the evidence. Quote, although legendary neurosurgeon Wilder Penfield reported eliciting an incredible variety of effects throughout the human brain, he never reported any non-motor effects in prefrontal cortex regions. Consistent with Penfield's findings, lesion studies from a century of neurosurgery research show that areas of the prefrontal cortex can be removed with little apparent change in conscious experience to the patient, whereas lesions in primary motor or sensory areas cause striking differences in content-specific perceptual experience. The apparent rarity of reports of conscious changes following IES of the prefrontal cortex raises the question of just how rare these effects really are relative to the rest of the cortex. A recent study we conducted shed light on this question. We analyzed IES-elicited effects across 67 neurosurgical patients and 1,537 electrode sites covering the entire cerebral cortex, exploring the probability that IES would elicit effects across all cortical regions in the human brain. We found a global gradient in the rate of elicited perceptible effects, with the highest chance, about 67%, of eliciting an effect in unimodal regions, such as the primary visual cortex. Conversely, stimulation of the most anterior prefrontal cortex regions, both medial and lateral, yielded the lowest elicitation rates in the entire brain. Effects were sometimes observed in particular prefrontal cortex subregions, however, such as the OFC and ACC. This study provided a large-scale quantitative confirmation of a conclusion already evident from qualitative assessments of the IES literature. Stimulation of the most anterior aspects of the prefrontal cortex, whether medial or lateral, almost never affects conscious experience. These findings corroborate those of a recent study showing only null results in sensory phenomenology in a large cohort of 36 patients in whom various medial prefrontal cortical regions were stimulated. Nonetheless, occasional exceptions to this general trend have been reported in isolated case studies, and the details of effects elicited in the OFC and ACC are also of considerable interest." Unquote. Okay, so what about those isolated case studies? Skipping forward to that part, the authors write, quote, Blank et al. 2000 administered IES in the left lateral prefrontal cortex of 2 patients. In patient 1, the authors reported complex visual hallucinations produced by stimulating 2 adjacent electrodes located in the ventrolateral prefrontal cortex. The patient reported, quote, all of a sudden it seems as if many things are coming at me. I can hardly see them at the same time. A church, a castle, a big room. Following stimulation of a neighboring site, the patient reported, quote, it seems to me as if a lot of thoughts are coming, but it seems to me as if I do not have the time to retain them all. In patient 2, stimulation of the posterior aspect of the dorsolateral prefrontal cortex directly anterior to the frontal eye fields similarly elicited an immersive hallucinatory visual experience. The patient described the presence of a young man in the room adjoining her own, as well as details of the man's clothing and physical appearance. The authors concluded that IES of the dorsolateral prefrontal cortex and ventrolateral prefrontal cortex could elicit immersive visual experiences similar to the episodic and dreamlike experiences usually only reported following IES of the temporal lobe, although they acknowledged that the reported effects could be understood as perturbations of ongoing conceptual thought processes rather than visual hallucinations per se, unquote. For what it's worth, I agree with the latter interpretation. The way to find out might be to suppress activity in the occipital lobe at the same time as they deliver the prefrontal cortex stimulation. This way, the question could be asked, is the prefrontal cortex sufficient to produce visual phenomenology? I think not. I think these two patients demonstrate altered cognition and imagination. In the first case, the subject said, quote, all of a sudden it seems as if many things are coming to me. I can hardly see them at the same time. A church, a castle, a big room. This is what I would expect if attention was being driven towards associational visual cortical activity, thereby amplifying or altering subconscious visual imagination. The only way to be sure is to conduct their study while simultaneously suppressing visual regions of the brain. I think this would abrogate all visual experience. According to the TICL, the system which is conscious occurs across a majority of the cortex and thalamus. The networks which produce contents are contained within it. Subsystems which produce content for the system are modulated by frontal cortical activities in a manner analogous to voluntary movement. Consider voluntary movement of the hand. The sense of wanting to control the hand, the impulse to do so, that is prefrontal. The motor cortex in the frontal cortex is under direct influence from the prefrontal cortex. This produces the initial signal to move. The hand moves accordingly, and sensory receptors in the hand send feedback up the spinal cord to the thalamus and onward to somatosensory cortex in the parietal lobe. Thus, we sense the movement of the hand occurring in the hand and what other sensations this produces. This alters the pre-existing subsystems reflecting that part of the body. They undergo change which is experienced by the system. It is experienced within the map of the body, situated in the parietal cortex, not in the prefrontal cortex where there is no such map. Likewise, visual sensations of the world occur in the occipital lobe. Attention directed by the prefrontal cortex and eye movements directed by the frontal motor cortex naturally alter the visual experience, but they do so indirectly. Attention alters which features are highlighted. It acts like a spotlight, amplifying certain things at the expense of others. This means that subsystems in the posterior brain, in the occipital lobe, and multimodal areas will undergo change. This will be experienced directly by the system as changes in perceptual content. Continuing from the article, the authors write, quote, Blank et al. 2000 therefore concluded that the observed effects more likely reflected changes in visual experience rather than conceptual or abstract thoughts. Importantly, this interpretation is challenged by recent evidence showing that stimulation of comparable anatomical sites in the left dorsolateral prefrontal cortex and ventrolateral prefrontal cortex yielded marked changes in thought content without any reported changes in perceptual experience. They described 3 patients who reported conceptual thoughts following lateral prefrontal cortical stimulation. For instance, one patient reported conceptual thoughts following stimulation to the left ventrolateral prefrontal cortex. Quote, I had a thought about a game that kids play in the summer. I can't think of the exact game. In another patient, stimulation of the left dorsolateral prefrontal cortex and middle frontal gyrus elicited thoughts about a person. In contrast to the reports by Blank et al. 2000, the patient was not able to describe the person's physical characteristics and confirmed that the experience was not visual in nature, unquote. This makes sense to me. I agree with Raccah, Block, and Fox. In their conclusion, they write, quote, We therefore conclude that IES of lateral prefrontal cortical regions does not reliably affect conscious experience as might be predicted by most prefrontal theories of consciousness. This conclusion is largely consistent with previous reports that patients with even major lesions in the prefrontal cortex show no apparent degradation in consciousness. However, there have also been cases in which lateral prefrontal damage does appear to impair patients' ability to consciously interact with the environment. And what lesion findings tell us about the role of the prefrontal cortex in consciousness remains intensely debated. It is also significant that the prefrontal cortex is not the only region of the brain where IES elicited effects are rare. Other high-level association areas also appear to share this property, e.g. the posterior cingulate cortex, and these trends appear to be driven by the brain's intrinsic network architecture. Low rates of IES effects are not unique to prefrontal regions, but appear to be a more general property of brain areas involved in abstract thought and complex cognitive function. although the lowest elicitation rates are nonetheless found in the anterior prefrontal cortex. In any case, the prefrontal cortex comprises many subregions, and various models of the prefrontal cortex in consciousness often propose prominent roles for areas other than the lateral prefrontal cortex. As we have shown, relatively rare but nonetheless reliable effects can be elicited from such regions, including the ACC and OFC. While the specificity of the effects in the OFC and ACC does not suggest a general role for these regions in consciousness, stimulation of these regions does result in reproducible changes in emotional experience and may provide support for recent accounts of higher-order theories of emotional consciousness. That said, the specific nature of most effects, whether visceral, somatic, olfactory, or emotional, as well as the lack of effects in ongoing perception, contradicts the notion that the prefrontal cortex has a general role in rendering existing perceptual representations conscious, unquote. If there are levers of control which we have over what we perceive, what we think, and how the body moves, they occur in the frontal lobe of the brain. Considering everything that we experience, there isn't all that much we have the power to alter at will. As I rest on the back deck and watch a duck walk across the neighbor's backyard, I have no power to choose its direction of motion. I cannot make an airliner disappear from view as I gaze up at the sky. I cannot change the sound it makes as it approaches overhead. These are passive perceptions, and all I can do with them, to the extent that I have any power over them at all, is to direct my attention and my processes of thinking about them. These capacities are limited too. It's not so simple as to direct myself inwardly, whatever I do, to not think about the duck. I can also avert my eyes, stand up and turn around, or look down at the ground instead of upward at the sky. Each of these actions that I seem to be able to take by voluntary will, these are functions of the frontal cortex. So the amount of control we have over our thoughts and actions should correlate with the size of the frontal cortex. It should be noted that the proportion of cortical gray matter taken up by the human prefrontal cortex is substantially greater than in other primates, and even more so compared to non-primates. If my analysis is correct, then it seems that we often ask the wrong question with regard to animal consciousness. Of course the monkey is conscious, in every way as conscious as you and I. The difference is in how much control it has over the contents of its own consciousness. We human minds exhibit a high level of cognitive control compared to other species, and I've noticed that we still don't have much. We are driven so much by thoughts and feelings and personal dispositions that are beyond our will to change, and yet we drive ourselves crazy trying. I also think that we become confused about our own identity. We think we are that which acts, but not that which is acted upon. We think we are the prefrontal cortex, roughly speaking. When we have an extraordinary experience of oneness or ego loss, we become plainly aware of the mistake. In fact, all that I see, and all that I hear, and each thought which is present to me, that is me too. I am not just the thinker, but the thoughts. I am not just the seer, but all that is seen. These perceptions are part of whatever it is that I am, outside of anyone else and therefore only real to me. I do not find thoughts that are outside of me, and I do not see objects that are outside of me, only the ones inside, composed of consciousness itself.